investigador en el Instituto Nacional de Técnica Aeroespacial y va a dar su charla a cómo corregir 1000 exámenes con un poquito de OpenCV. Un aplauso.
Okay, so the interesting thing of this topic is the materials. I have uploaded the scripts and your Python notebook, and you can get them in GitHub, or you have a link in the agenda of the event. Because the presentation is only about how do we get this script to unfold and how can we correct the exams, and what is Numpy, what is Matplotlib, what is OpenCV is like a presentation level, not really advanced. We will not really look into the concept, but just a quick presentation, something so you can get a feel of what these libraries are. So, what happened? So, because of reasons, it happened that I had to correct 350 tests in 1 week because my boss has to do it, but he hadn't any time to do it. So he said, can you do it with Python? And I was like, I can say, yes, I can do it with Python. Or I can say, no, sorry, I can't. So I said, no, sorry, I can't. So he said, so you do it by hand? And I said, okay, I will try Python. So, okay. In Spanish, we call this really piece of brown. But yeah, so I have to learn OpenCV and Python in order to do this, because it had to be done. It's just like that. So, let's start at the beginning. What is an image inside a computer? Okay, so I had like 350 images in JPG file in my computer that I have to correct. So what is an image in itself? So for example, for a grayscale picture, it's as easy as each pixel of the image is a value inside a matrix. So each number inside the matrix is the amount of light that the pixel have. In grayscale is as simple as that. Black is a zero light, and white is 255. It's all the light that the screen can project. When we go to color, it's a similar process, but we have the image divided in 3 matrices. One for blue light, one for red light, and one for green light, that when you combine in different amount, you get the different colors of the image. But in itself, every one of the channels are just a matrix, like the black and white image. So, okay, we can translate our images to matrices in order to work with them with mathematics and computer things. So we need a library in order to operate with matrices. So, Numpy. Numpy is a library which contains a lot of very useful scientific functions that will help us to work with matrices, arrays, vectors, and that kind of mathematical constructs, okay? So the key point of Numpy, I think, is the array object, okay? Arrays, I will explain later, are the key of Numpy, and the libraries, the functions that come with this library that operates on matrices and arrays make our code go really fast compared to Python. So, arrays objects. In an array, you can store like a vector. It will be like one-dimensional array. You can store a matrix, which will be a two-dimensional array. And you can use an array to get like a 5-dimensional matrix, if that's your thing. I won't king shame you for that, but for this presentation, we will use only 2D arrays, that means a matrix, and one-dimensional arrays that are vectors. So, that means if inside an array we can store a matrix, and a matrix is an image, we can use Numpy to work with our images, which is great. It's like a next step in order to analyze our exams. So, from NumPy, what will we use concretely in order to work this algorithm? We will use array functions that work on the whole array. That's the key to the speed of NumPy, because the way the information is stored inside an array makes it go very fast, because they are like the same type and go one next to the other in memory. It's a complicated thing, but it goes very fast when we use the NumPy functions that are prepared to work with that kind of objects. And we also will work with a very useful tool that it's called slicing. When we index a list, for example, we can get the second element, and if we have a list of lists, we can get like the first element of the main list is like the second list, and then we can get the second element of this list. So when we work with arrays, we can compact this expression in a very handy way. It's very easy to work with slicing. So we can get submatrices in order to work with smaller pieces of our main matrix or image. So, okay, how can we get the image in JPG file to an array in NumPy? And how can we work with more image functions instead of like the numerical and mathematical function of NumPy? So we will use just a few functions of OpenCV. OpenCV is a library written in C, C++. It's open source, and it's like the most important, I think, library for artificial computer vision. And it has like a very nice interface with Python that you can use with total ease. So, what will we use OpenCV for? So the first thing that we are going to do with OpenCV is load the image inside a NumPy array, just like that. The first line loads them, and the second just translates it to black and white in order to have like a single matrix and not the 3 channels. Okay? And wait. Another 2 interesting functions that we are going to use are the blur in order to diffuse the image, and the threshold that allows us to sharpen the image or even binarize it in order to have either all white or all black. Another thing very useful that we will use is more like computer vision, but it's like one of the fundamentals of computer vision, I think. It's find contours. This function finds the border of the areas of the image in order to find shapes inside the image, okay? I will tell you later what will we use. And okay, up to this moment, we have worked with arrays, with matrices, and everything is okay, but we are on the screen only seeing numbers and letters and codes, and it's like, we're working with images. We have to see what we are doing. We cannot go blindly into it. So, Matplotlib is a library that will allow us to plot, to represent graphically what we are doing. And I think it's very important, please, when you have data, always plot your data, okay? Always represent what you are doing, because there are a lot of information that visually you can get very easily, but if you only see the numbers, you won't get any information of it. So, Matplotlib comes with a very useful interface, which is pyplot. It's like a sub-library inside Matplotlib that we will use to use very quick functions in order to plot with only a couple of lines. Okay, so the Matplotlib functions that we will use mainly are plot for lines, scatter in order to display points of data. Contour is also a very useful function because it will display like height lines inside a 3D surface, and imshow that shows a matrix. For example, you have there a 10 by 10 elements matrix. So, okay. Yeah, everything was right. There are a lot of libraries that are very good, but we were talking about exams, right? What happened to them? Okay, so using these tools that we have seen, we have to correct exams, okay? So, how can we do it? Okay. So, okay, how was the exam? This was the kind of exam I had to correct. As you can see, it has the upper side where you can write your identification, and there are 5 columns of data. Each one is composed of 20 cells in which you have to cross which is your answer. So we have to search these cells and check where is the answer. So the rules for this test, I don't know why, I just received the test completed, was draw an X on your chosen option, circle the X in order to nullify it, because I don't know why is that, but I guess it's what I have to do. And then I have to collect for each question, which was the selected answer, which was the nullified answers, if there were any, which were on blank, and everything. So, okay, how can we do it? Okay, the first thing that we have to do is like precondition our image. So, from this scanner, it comes this exam that is like turned a bit, and it's also a bit noisy. So maybe the algorithm, the contour detection, maybe can fail because of the grain of the image. So we have to correct this in order to get like the proper contours. So the first thing we're going to do is blur, and then threshold. That are like opposite operation, but will give us a very clear, very well-defined contours to operate with. So once we get this, we can easily detect the contours. So we can detect the orientation of the exams just by measuring how is the 5 main columns, which are the 5 biggest contours of the image. So we get the exam upright, so we can just operate with all the exams in the same position, and then we have to detect and extract the useful data, which are these columns. For each column, we can mathematically divide it into the 20 questions, the 20 cells, and for each cell, we have to detect if there's any mark, and if there's 2 marks, which of them is a circle. So, okay, you can at this point use a very advanced algorithm that will recognize how the X correlates with a matrix in order to understand what's happening. But I had a week which the only thing I did was compare the amount of brightness of each cell. I mean, okay, so if you have to write, you will put ink on the exam, so there will be less light in this cell. I guess that's a mark. And if you have 2 marks, probably if you have to circle, you will have more ink. So if you have 2 detected answers, the darker one will be a nullified answer. That was the theory, and sometimes works well. So we have also to be prepared. So when there's, for example, 2 answers and when we are like uncertain of whether there was like a real mark or it was like some shade on the paper or something, you have to be careful. And for example, what I did was just mark it with a yellow rectangle in the final image. So I analyzed the whole exam, and I store the answers, and on the other hand, I store this image that will just draw a a green rectangle over my detected answers. It doesn't matter if they are the right answers to the question of the exams. It's only what I think the student has marked as an answer. And with red, what I think that the answer marked as a nullified option. And I also store for every cell if I had doubts about what I just read. So I draw a yellow rectangle over every cell that I wasn't sure if it was right or wrong. So, okay, that was the theory. But reality always comes at you, and sometimes it's difficult to assign thresholds to the image, because sometimes the students want to make very sure that the X is very clearly written, so I can apply the difference of darkness. Sometimes you have only one answer, but it's nullified, so I don't know how to detect it by itself. Sometimes the cells doesn't even have the same size. I don't know how the people who designed this test made it, but well, I have to work with this. I have to take it on account. So I just ran a little optimization algorithm in order to minimize these distortion effects while correcting and reading properly. And, well, okay, you will always, anyway, doesn't matter how prepared you are, the students will surprise you with their answers. Okay, so this was nice. You have to be prepared to detect 2 nullified answers at least. And even more esoteric things, like, why? I can't even correct this by hand. So, yeah, okay. I just had to mark it in yellow and later decide what to do with it. So, okay, once we have the exam corrected, we just can run into a loop, and we can check the images that we generated, and we can easily check if all the yellow boxes, in order to, our algorithm detected correctly the answers. So, yeah, okay, so the algorithm was made, and everything goes at least reasonably right. And there was like a bit of additional libraries I used, but they are not so drastical to the final result. For example, imutils is a very small library made from useful functions. For example, in order to straighten the image, it was an already made function in imutils. With OpenPixel, I read and write Excel files because I don't work alone. I work in a team, and I have to do this. And yeah, OS is the operative system functions in order to detect whether a file exists or not. And well, this whole project was based on a tutorial that my boss sent to me in order to try to adapt to our test. I will thank you forever, Adrian Rosebrook. If you ever come to Spain and see this, I will send a beer to you because you saved my life, basically. And thank you. That's all.
Thank you, Siro, for your presentation. Sorry for introducing you in Spanish at the beginning. You can ask questions now. If you ask in English, he's going to answer in English. Si preguntáis en español, pues va a responder en español. ¿Alguna pregunta? Any question? I have a question.
Sí, ¿por qué?
Has dicho así muy por encima, hice un algoritmo de optimización para minimizar el error de no sé qué, lo has dicho en una frase, ¿podrías elaborar un poco, comentar más?
Bueno, eso, a ver, parece como que es mucho, ¿no? En plan, oh, un algoritmo de optimización. No, en realidad lo que hice fue escanear 5 exámenes en blanco y luego analizarlo muchas veces con diferentes parámetros de cuál es el área que tengo que analizar de cada cuadradito para intentar que entre los blancos detectara lo mínimo posible, pero con los valores de cajas más amplios posibles, para intentar detectar siempre que se pueda. Y ya está, eso. Si lo haces muchas veces y miras qué es lo que sale, pues se optimiza. básicamente. ¿No?
En un momento has comentado que corregías la orientación del documento, pero ¿cómo distinguías si estaba
Vale.
o podía estar?
Esto es una cosa muy chula que se me ocurrió en un momento de genialidad. Nada, en realidad es una chorrada. Cuando utilizas contour, detectar los contornos, entonces muy fácilmente puedes detectar los contornos de las 5 barras, porque son los contornos más grandes que hay. Entonces, hay otra función que tampoco hemos entrado en detalle, pero está comentada en el código, que lo que te hace es como redondear a la forma de lados planos más parecida, por ejemplo, en rectángulos. Entonces, a partir de esa forma te da los vértices, y cuando tú tienes los vértices puedes ver el lado grande y el lado pequeño, y lo comparas, y entonces tú ya sabes la orientación que tienes, y te quedaría una incógnita en saber si está así o para el otro lado. Pero entonces lo que haces es mirar dónde está la cabecera, porque tú el resto lo divides en 2 partes, y en el sitio donde haya más oscuridad, pues es la cabecera, porque al otro lado no hay nada. Y entonces ya lo pones derecho.
¿Alguna pregunta más?
Dime.
¿Por qué el desenfoque después del enfoque y no, por ejemplo, aplicar un threshold para hacer la primera?
Porque si haces el threshold directamente en la imagen con ruido, puede coincidir que tenga polvo el escáner y se te rompa el contorno. Entonces te sale ahí un cacho blanco que te rompe el contorno y eso ya se va... O sea, los dibujitos estos tan chulos con el cuadrado rojo, si te pasa eso, se ve como de repente a un cuadrado le falta así un cacho y te sale, te detecta cosas raras, en plan preguntas donde no hay, cosas así.
¿Alguna pregunta más?
¿Tuviste muchas reclamaciones a posteriori?
No, afortunadamente, si las hubo, se las comió mi jefe. No, pero en serio, la principal gracia de esto es tener uy, para el otro lado. Los exámenes corregidos en colorines. Los colorines, en serio, los colorines salvan vidas. En este caso, si tienes todos los exámenes corregidos así, tú simplemente vas pasando con el visor de imágenes y vas viendo todos los cuadrados amarillos que estén bien. O sea, que está el cuadradito verde en la X buena y el cuadradito rojo en la X tachada. Y tú vas así comparando, pues que no haya falsos positivos, falsos negativos. En cualquier caso, siempre va a ser mucho mejor que hacerlo a mano, examen por examen.
¿Una última pregunta?
¿Has tenido ocasión de reaprovechar el código más allá de esos 350?
De momento no, pero mi jefe me quiere enmarronar aún más con esto para corregir muchos más. A ver, una vez que está el código hecho no es para tanto, pero... Hombre, en cierto modo también, ya que está hecho, pues está guay usarlo. De todas maneras, si vosotros le veis uso, está en GitHub, cogerlo tal cual, le dejáis un comentario al autor del artículo original que hacía los tests estos de burbujitas de Estados Unidos, le decís que os ha molado mucho también. Y si le veis uso, lo descargáis de GitHub, lo tengo como un notebook de Jupyter, lo tengo también como script de Python, así que lo podéis usar como queráis.
Bueno, pues ya si queréis alguna pregunta más, seguro que estaré encantado de contestarlas en los cafés. Muchas gracias.
¿En serio? ¿Os ha gustado? Ay.